Hey friends, so now we're going to talk about a very special kind of indexes in databases. We have the Columnstore index. This topic is very confusing for a lot of developers, but now what we're going to do, we're going to deep dive on how SQL works with the Columnstore index and why it is very important for big data and data analytics. And of course, we're going to go and practice by creating this index. So let's go. So now let's say that we have a table. We have multiple rows and multiple columns. Now, if we use a Rowstore index, this is the classical one, what's gonna happen? Our table gonna be splitted into multiple rows. And as we learned, each group of rows is gonna be stored inside a data page. So that means we are organizing the data row by row, which means all the columns for each row gonna be stored together. This is the traditional way on how the databases organize their data, where the informations are stored row by row. But now on the other side, if you use Columnstore index, the SQL gonna go and split your table into multiple separate columns. And then SQL gonna go and store the values of one column together in data page. So that means if you go and open a data page, you will find only the values of one column. You will not find the entire row. So if it's like the first name, you will see only the first name informations. You will not see the last name information in this data page. So if you compare them, the Rowstore index stores the data row by row. The Columnstore index stores the data column by column. So this is a very high level representation on how the Columnstore index is stored. As you know me, we go in details in order to understand exactly how SQL works with the Columnstore index. So let's go. Alright, so now let's say that we have a table for the customers. We have 3 columns, ID, name, and status. And as well, we have around 2 million rows, 2 million customers. And as we learned as a default, the table can be built as a heap structure where the rows are stored row by row inside data pages. But now we go and create a Columnstore index on top of this table. So now once you do that, SQL gonna go through a process in order to build the Columnstore. So the first step is SQL gonna go and divide the data, the rows, into row groups. Now in SQL Server, each row group can contain around like 1 million row. So in this example, our table can be split into 2 row groups. The first 1 million row in one group and the second one in another row group. Now you might ask me, we are talking about columns, why we are splitting the rows? Well, this is just a pre-step in order just to optimize the performance and to do parallel processing. And of course, the data will not be stored like this because we have the second step. Now in the next step, SQL gonna go and segment the columns. So now SQL will go for each row group and start splitting the data by the columns. And that's why we call it a column store, because we are separating the columns from each others. So that means we have one segment for the ID, another one for the name, and a third one for the status. And this can happen for each row group. And now SQL move to the third step in this process. We have the data compression. And this is the most important step in this process because it is the reason why Columnstore is very fast compared to the Rowstore. So in this process, there are like different techniques on how to do data compression. And the most famous one is that it's gonna go and create like a dictionary. Let's take, for example, the column status, the status of the customer, whether it is active or inactive. So the word active and inactive gonna be repeated like 2 million times because we have 2 million customers. And since it is like string, it is like taking a lot of space and storage. But now instead of that, we're gonna go and compress the data. So first, SQL gonna go and create a dictionary by replacing the value active and inactive into smaller values like 1 and 2. So we have like a mapping between the long value to a small value. And after that, SQL gonna store like a data stream where we have like only 2 values, 1, 2, 1, 2. So we can have like a big stream of 2 million rows. So SQL gonna go and do this for each column, and with that, the size of each column gonna be changed. Depends, of course, on how much different values you have in each column. So this step is very important in order to reduce the size of the data and as well to increase the performance. So now once everything is organized and compressed, SQL gonna go and start storing the results in databases. But here SQL will not use the standard databases that we have learned previously, but instead it's going to use a special database called LOB, large object page. So now let's quickly compare the structure of the normal data page that we have learned in the Rowstore with the new one, the Columnstore, the LOB data page. So as usual, each page has a header. This is same as any data page, but the next section is going to be the segment header. It has like metadata informations about the column segment that is stored in this page. Like we have the segment ID, the row group ID, the column ID, and it has as well very important information, the ID to the dictionary page. So the dictionary page is as well a type of pages in SQL. It has as well a header, but inside it we have like a mapping. So it maps the original value, the long one, the inactive, to the smaller version of this value. For example, 1. And that's all for the dictionary page. It has the mapping between the original values and the smaller values. And beneath the segment header, we're gonna have now the important place where our data can be stored. We have the data stream. So it is like sequence of IDs from the dictionary that represents the values of the columns side by side. And of course, we cannot fit the whole 1 million rows inside this data stream. We're gonna have like multiple LOB data pages. So this is how exactly the SQL stores your data if you decided to go with the Columnstore. So let's go back to the process. So back to the process, as you can see, SQL is storing the data as LOB data storage. So this is the last step, and with that, SQL did convert your table into a column store. So now we cannot just create a column store without defining whether it is clustered index or non-clustered index. So let's start with the first one, the clustered column store index. So if you create such an index, SQL, of course, will not be building a B-tree structure. SQL gonna use exactly this structure, the column store structure. So as we learned, the clustered index is a complete makeover of your table. When you apply it, then SQL gonna format everything column-wise. And it is fully replacing the old row-based table structure that we have at the start. So once you apply the clustered column store index, it will not leave anything behind, and your table gonna be completely structured as a column store. And one more thing, which makes sense, of course, all the columns from the original table gonna be converted to a column store. So it is not leaving anything behind it. But in the other hand, if you are using a non-clustered column store index, as we learned, it is like a companion to your existing table. So it coexists with the table and it will not replace anything. So the column store index gonna be an additional thing that is stored beside your table. So that means the original table will not be deleted at all like the clustered column store index. The first one is in the old row-based storage, the regular table, the first one, and your data gonna be as well stored in a separate structure in the column store index. And of course, in the non-clustered column store index, since we are creating an extra index outside of your original table, you can go and define which column should be included in this process. It must not be all the columns. You can go, for example, with only the status. So that means you build a column store index only for one column for the status of the customers. So this is what we mean with the clustered column store index and the non-clustered column store index. Alright friends, so now you might ask me why we are doing all those stuff, why I would split my data by the columns. Well, it's all because of analytics. Because in analytics we have like big complex query where we have a lot of data aggregations and stuff on big tables. And the Rowstore index is perfectly designed in order to improve the performance of such big queries. And that's why SQL databases like SQL Server and as well BI tools like Tableau and Power BI did adopt this method in order to offer fast platform for data analysis. So now let's understand exactly why the column store index is way faster for data analysis than the Rowstore index. So let's go. So again, we have the customers tables, and let's say we have like 5 customers where we have ID, name, and status. And as we learned before, if we are using Rowstore index, the data can be stored in multiple data pages, and in each data page, we're gonna have the whole record, the whole information about one customer. So for this example, we're gonna have like 3 data pages. But if we are using the Columnstore index, it's gonna be stored a little bit differently. So the first column, the ID, gonna be stored in one data page, and here the SQL will not go and build a dictionary because the IDs are already short. So we're gonna have like one data stream with all IDs. And now for the next column name, it's gonna be stored in separate data page, where we're gonna have an extra dictionary page where each name gonna be mapped to one small value. So the data gonna be compressed and we're gonna save storage. Now the database is gonna create for the third column, the status, one more data page, and the dictionary here gonna be very small. So for active, we're gonna have one, and for the inactive, we're gonna have two. And in the data stream, we will be storing only the IDs of the dictionary. So now let's understand why the column store is faster. Let's have the following query. We want to find the total number of customers that are active. So we have the query select count star from customers, and we're gonna filter the data by the status where it is equal to active. So now if you query the table with the Rowstore, what can happen is SQL have first to go and collect the data. So it's going to go to the first data page and collect the first two customers, then to the second, to the third, and so on. And as you can see, SQL here is reading everything, the whole row, the ID, the name, the status, even though that for the query, we don't need all those informations. We just need to count how many customers we need with the status active. But still, SQL cannot go and selectively only reading the status. SQL has to read the whole record. So after SQL has all the data, it's going to go and filter the data. So it's going to go and remove the inactive rows. And then SQL gonna do the aggregate operation, and with that we're gonna get 3 rows. So that's why the total count of active customers is gonna be 3. But now let's see how SQL gonna query the column store. So SQL first have to analyze, okay, which columns do I need actually for this query? Well, we need only the status. So SQL will not go and open all 3 data pages and read it. SQL will target only one data page, the data page where we have the column status. So it's gonna take this very simple data stream, and then it's gonna go and understand the dictionary, and it's gonna go and remove all the values where it is equal to 2. So with that in the output, we have only 3 values, and SQL gonna go and do a very quick count for those values. So in the output, we will get as well 3 total number of active customers. So now if you compare this intermediate result sets from the Rowstore and the Columnstore, you can see that in the Rowstore we have fetched and retrieved a lot of unnecessary informations for this query. And this of course going to make the speed of the query very slow. But in the Columnstore, SQL reads exactly what it needs for this aggregation, and we didn't read any extra informations about the names of the customers, the IDs. It didn't like open any extra data pages. It exactly gets the data that it needs for the aggregation. And that's exactly why the performance of queries where we have aggregations and data analysis is gonna be very fast if you are using Columnstore compared to the Rowstore. So that's why we use Columnstore for big data and data analytics. Alright, so now let's summarize the differences between the Rowstore and the Columnstore indexes side by side. So let's start by the definition. The Rowstore gonna go and organize and store the data row by row. It is really nice method if you need a lot of columns in one row. But in the other hand, the Columnstore index gonna go and store the data and organize it column by column, which is really great if you're focusing on specific column. Now, if you are talking about the storage efficiency, the Rowstore index is gonna take more space compared to the Columnstore index, and that's because, as we learned, the Columnstore gonna go and compress the data, which gonna save a lot of storage if you have large tables. Now to the next point, which is more important, about the performance, the read and write optimizations. We can say for the Rowstore, things are more balanced, so you will get a decent speed for both write and read operations. But things in the Columnstore is different. It is fast for reading, especially if you are doing data analytics, but writing data like inserting and updating, it is slower, because as we learned, there are like multiple steps until the data is written in the pages. So in one hand, you are optimizing the speed of your analytical queries, but in the other hand, changing data, it is slower than the Rowstore index. Now let's talk about the next point, input and output efficiency. Well, the Rowstore index, it's not really good because you are retrieving a lot of columns. So a lot of data should be read from the disk storage in order to answer your queries. But in the other hand, for the Columnstore, it is lower, and that's because it targets exactly the data and columns that is needed for the query. So there will be generally less data that is read from the disk storage. And of course, that's why we are getting fast read performance. So now if you are thinking thinking which systems are best for Rowstore index. Well, the Rowstore index is very suitable for the OLTP systems, online transactional systems like banking and commerce systems, where the full records are accessed very frequently. But in the other hand, the Columnstore index is great for OLAP. OLAP systems are online analytical processing, where you have like data warehouses, data lake, business intelligence, you are building reports and analyses, you have large data sets and very complicated aggregated queries. So if you have such a project, then the Columnstore index is the way to go. So that means the use case for the Rowstore index, if you have high frequently transactions where the system has to quickly access records. And the use case for the Columnstore is big data analytics, where the SQL has to scan large data sets. So those are the main differences between the Rowstore index and the Columnstore index. Alright, so now let's check the syntax of the Columnstore index. Well, it is really easy. What we're gonna do, we're gonna just put a Columnstore keyword between the clustered or non-clustered and the index. So once you specify that, then you are telling SQL you want to create a Columnstore index, and the rest is gonna stay as it is. Now, if you want to create a row column store, then you don't have to specify anything. There is no keyword for the row store. So as we learned before, we can go and create a non-clustered index and clustered index, and both of those syntaxes gonna tell SQL we are creating Rowstore index. But if you go and use the Columnstore keyword, then you are telling SQL that you want to create either clustered or non-clustered Columnstore index. And here there is like a syntax rule. If you are creating a clustered column index, then you must not specify anything for the columns. So you cannot go and specify anything like an ID or country or any columns over here, because it makes no sense. Once you say clustered column store, then all the columns gonna be included in the new structure. So this is the syntax of the Columnstore index. Alright, so back to SQL, let's check how we can create Columnstore index. Now, if you check our table here, DB customers that we have created previously, and we go to the indexes, you can see that you have created few indexes, and one of them is the clustered index. This one is a Rowstore index. So our table is splitted by the rows. Now let's go and change that. Let's make our table splitted by the columns using the Columnstore. So we're gonna say create clustered column store index, and we're gonna give it the name index DB customers, and it's gonna be on the table sales DB customers. And here, if you go and specify a column, it's gonna be a mistake. So let's go and check that. So if you go and execute it, it says it fails because key lists or the columns is not allowed. So we cannot have this. So let's remove it. And now we have the correct syntax. Let's execute it again. We will get another error because it says in one table you cannot have more than one clustered index. We have already one. You have to decide, do you want to split your table by columns or by rows? That's why we have to go and drop the previous index. So we're gonna do it like this, drop index, and I need the name of the index like this, and then we have to specify the table name. So that's it. Let's drop the index. Now if you refresh, we cannot see anymore. Our clustered index and our query should be working. So let's do that. Now let's check the indexes again. And now, as you can see, we got a new clustered index, but this time it is Columnstore. Now you can see at the start we have like an icon. It looks like a bar chart or like analytics and reports. And that's because the main purpose of creating Columnstore is to have a bar chart. So now, of course, we cannot go and create multiple clustered column index. We can have maximum only one. So now if you say, you know what, let's go and create for the first name another index, but this time it's going to be a column store. So if I go and copy the whole thing over here, and let's say it is non-clustered column index, and let's call it, for example, first name, and we define over here the first name So that's it. Let's go and execute it. You will see that we will get an error where SQL tells us you cannot create multiple column store indexes. That means you can create only one column store index for each table, and you have to decide whether it is clustered or non-clustered. And you cannot create, like the Rowstore, multiple non-clustered index. So you are allowed only with one column store index. But this limitation is only here in the SQL server. In other databases, I know that is allowed to use multiple column store indexes. Like in the Azure SQL Server, you can do that. So now, in order to practice and you would like to create a non-clustered column store index, you can drop the first one and you can go and create the one that you need as a non-clustered index. So actually, let's go and do that. Let's drop the first one. So drop index. This is our index on this table. Let's do that, and once you execute, the non-clustered column store index is gonna work. And if you refresh over here, you will see that we have a non-clustered column store index for the first name. Okay, so now as we learned that the column store gonna go and compress the data, and the storage that is needed for the entire table gonna be less than the Rowstore. So let's see whether that is really true. Now, in order to check this, I will not do that in the database sales DB because everything here is already small. We're gonna go and use another database. We have the AdventureWorks DW 2022, and if you have a newer version, that's okay. So now what is the plan? We're gonna go and create 3 identical copies of one table, and we're gonna have different structures. So the first one gonna be the heap structure, the second one gonna be Rowstore structure, and the third one gonna be column store structure, and then we're gonna go and compare the storage of those 3. So now we have to go and pick one of those tables. We need one big table, so for example the fact internet sales. So let's see how we can do that. Let's start with the heap structure. We're gonna say select star into a new table, so it's gonna be the fact internet sales and underscore HP for the heap, and we're gonna get it from the table facts internet sales. So like this, and here it's very important, if you are switching databases, you have to go and use the database. So it's going to be use AdventureWorks DW 2022. So execute this at the start to make sure that you are switching to the new database. And now let's go and execute our heap structure. So with that, we have created heap table. As you can see, 60,000 rows. And since we didn't define any clustered index, this table is going to be a heap structure. Now let's go and create another table where we use clustered Rowstore index. So what we're going to do, we're going to copy the whole thing over here, and we're going to call this Rowstore, and we're going to go, of course, change the name to RS, but still we are targeting the same table. So let's go and execute this at the start. But now in order to make it as clustered Rowstore, we have to go and create an index. So it's going to be like this. Create clustered index. We don't have to specify the Rowstore because it is as a default, it's going to be Rowstore. So let's call it index facts internet sales RS, and then the primary key, so B key, and now we need the table fact internet sales RS. And now we need the columns, the primary key. Well, actually, I don't know what is the primary key, so let's go and check that. So it is a composite primary keys, so it's going to be the sales order number and sales order line number, like this. So let's go and execute this. And with that, we have clustered row index. I'm going to go and check what do we have over here. So let's go and refresh everything. So we have now 2 tables, the heap and the Rowstore. So let's extend it and check the indexes. And as you can see, we have the clustered index. Now we need the third table. It's going to be the column store index. I'm just going to go and copy the whole thing over here. So this is the column store. Going to be here CS and CS. And of course, we don't need any columns for the column store. And don't forget to add the column store keyword. So create clustered column store index. And we have to rename as well over here. So let's go and execute our new stuff. So we create first the table and then we convert it to a column store index. So let's go and do that. And we have to go and refresh and check our tables. So this is our third table, and let's go and check the indexes, and we have clustered column store. Alright, so now we are done. We have our 3 different tables. Now let's go and check the storages of those 3 tables. So now let's go and check our first table, the heap table. So right click on it and go to the properties. And now we can see here a lot of information about our table, but we are interested on the storage. So click here on the page for the storage. And now we can see here a few informations about the storage. And one of them is the data space. It is around 9 megabytes. And the index space is almost nothing. So we don't have anything over here. So this is the storage of the heap structure. We don't have any indexes. Let's go now to the Rowstore. So we're going to go to the RS and properties. Then let's go to the storage. And now as you can see, the data space is exactly the same. And that's because whether it is heap or Rowstore index, we're going to store the data in data pages as rows. So the size of the data itself will not change. It will be sorted differently. But what's changed here is the size of the index. Now we are consuming more storage for the index. So that means the overall storage of the table with a clustered Rowstore index, it is more than the heap structure. Let's go and check now our Columnstore index. So to the CS, and let's go to the properties. And now it is interesting to see whether our table is getting smaller. So let's go to the storage. And as you can see, the data space is around 1 megabyte compared to the 9 megabyte. I know those are small numbers, but still it is massively reduced space because everything is compressed. And of course, we are not using any index spaces because we don't have this B-tree structure in the Columnstore. So as you can see, if you compare it to the others, it is the winner. This table that is using the Columnstore is consuming way less storage than the others. So now if you want to rank it based on the storage, the best one is the Columnstore index table. Then the next one is the table with the heap structure, and the worst one is the table with the Rowstore clustered index. So that's true, the Columnstore index is consuming less space than the other type of indexes. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.